algebra students, Mr. Lawrence here with your next flipped lesson. Who else would it be, right, Zach Miller? All right, today we're going to learn about dividing variables with exponents. Last night we were doing multiplying with exponents, and remember we saw things like this where we had like 3x to the fourth times, I don't know, 5x to the fifth. And we multiplied our coefficients and we got 15. And then we said, hey, we got x to the fourth, x to the fifth. The shortcut was to just add the exponents. But remember why? There's 4x's being multiplied. There's 5 more x's being multiplied. So altogether, there must be 9 x's being multiplied. And that was pretty simple stuff. Now, today's lesson is just as simple, except I don't like division symbols. You guys know that. Actually, it's not that I don't like them. It's that fractions makes math so much easier. I'm going to rewrite this problem as 12x to the sixth over 4x to the fourth. You'll almost always see me write it this way. It's not that I can't do it the other way. It's that this way just makes so much more sense. All right. Now the first thing I'm going to do is I'm going to simplify my 12 fourths. Won't that become 3 over 1 if I simplify that, right? You get a 3, you get a 1. Now this 1 may be unnecessary. I don't know yet. I'm going to leave it there. Now, when I have x to the sixth over x to the fourth, doesn't x to the sixth mean x, 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 and x, and x, and x, all being multiplied together, right? Now, x to the fourth is this, okay? And so, watch this. This is pretty nifty stuff here. If I have x divided by x, don't they cancel out and turn to 1? And then, oh, I know what I should do. I should say, not I should say zip, zip, right, Mr. Barabash? Okay, and then I should cancel those x's, right? And cancel those x's. Now, there's no other x's being divided, so nothing will cancel. So my numerator is going to end up being 3 times x over 1. And of course, a simpler version of that, x times x is x squared. Just ask Alexis Sarris from last year. She'll sing you a song about it. And multiply by 3. So I'm going to have 3x squared. If you're wondering why x times x is x squared, well, remember, there's 1's here for exponents. Or you could ask yourself, is 5 times 5, does that equal 5? No, of course not. It could equal 5 squared, but not 5. All right, so my answer for this one, oops, my eraser is not working. The button must be broke. Do it that way. And so my answer for this one is 3x squared. Now, check this out. I'm going to do problem number 1 here. I'm going to write 25 x to the 6th, y to the 4th, over 5x and y squared. Now, I'm not going to write them all out every single time. Okay, it gets too tedious. I know I can simplify 25 fifths. I'll have a 5 in my numerator. I'll have a 1 in the denominator. I may drop that out later. We'll see. I've got 6 x's in the numerator. I've got 1 x in the denominator. They'll cancel. That'll leave me 5 x's in the numerator. The y's will give me 4 y's in the numerator, 2 y's in the denominator, and I'll have a y squared. And then I shall have 5x to the 5th y squared. There you go. Pretty simple stuff. Now, I don't know if you noticed something yet, but remember that when we had like a, x squared times x cubed, we added the exponents and we got x to the 5th, right? Can you tell what's happening yet? Watch closely on this next one. See if you can tell what's happening. All right, I'll do this one in blue so it shows up a little bit better. Again, I like to write them as fractions. You don't have to, but I like to. 36, 36 x to the 4th y z to the 8th, and that'll be over 12 x cubed y z. All right, going to simplify this and turn it into 3. x to the fourth over x cubed is going to be a plain old x. The y's are going to cancel, and then I should have a z to the seventh. Did you see it? Did you see it? Huh? Did you see it? Check this out. Maybe you caught on, maybe you didn't. I will draw attention to it now. Do you notice up here on this first one, this first example, I had 12, or x to the sixth, and I had x to the fourth. And look at my answer. It had x squared. Yeah, look at that. On number one, when I had x to the sixth, I have x to the first. And look at this, I got an x to the fifth, didn't I? Here I have an x, a y to the fourth, a y squared, and a y squared. Yeah. Can you tell what's going on? I have 4, I have a 3, I have x to the first. The y is canceled. Z to the eighth, z to the fifth. Ooh, I have a mistake there. Danger, Will Robinson. Sorry about that. I do apologize. Where's my eraser? I can't find it. Eraser. Okay, that z to the seventh. This doesn't look right. Oh, I see the mistake. The mistake was I should have had z to the fifth down here in the denominator right there. I wrote it down wrong, and that'll get me a z cubed, right? Z cubed. All right, so when I have an 8 and a 5, I ended up with a 3, didn't I? And my simplified answer is that. What rule can you make? Well, when the bases are the same, what is going on? My smartboard is possessed, or my computer. Hold on a second. Let me. That's pretty crazy. I didn't intend for that to happen. There we go. So when the bases are the same, there it is. There's the tay I was telling you about. Same in division. It'd be wonderful. I knew how to spell. In division, you subtract the exponents. Yeah, you subtract the exponents. When the bases are the same in division, you subtract the exponents. Remember, when the bases were the same in multiplication, you added the exponents. So let's come down here and see if we can't do this next problem a little bit quicker. Well, let's see here. Where does my airliner get on there, buddy? Hello, there we go. Okay, let's get a nice little pen going on here. And I've got 40 divided by 10. I get 4. This might confuse you. X to the fourth divided by x to the fourth. You might go x to the 0. You may not know what x to the 0 is, but I'll bet you know what x to the fourth divided by x to the fourth is. I'll bet you know that that's 1. Well, if x to the fourth divided by x to the fourth is the same as x to the 4 minus 4, then it has to be the same as this, which means this must be equal to 1. So in other words, the x to the fourths cancel out. Now, y to the 7th divided by y to the 6th, 7 minus 6, 1. And there you go. Now, in a problem like this, you're likely to get screwed up if you don't go the fraction route. I'm going to suggest a fraction. So I'm going to rewrite it as 20 x to the 6th, y to the 8th. I'm going to put that over 40, x to the 7th, y to the 10th, and I'm going to simplify. 20 over 40 is going to be the same as 1/2 x to the 6th over x to the 7th. Well, won't there be an x left in the denominator? I mean, wouldn't it be this? Oops. I guess I can do it that way. And then there's 6x's being multiplied, and then 7x's being multiplied. Cancel, 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 cancel. Look, there's an x left, but it's in the denominator. Yes. Okay. Now, I have y to the 8th over y to the 10th. Isn't that going to be a y squared in my denominator? Okay. All right. Now, don't get too bent out of shape out of this. What I want you to retain from this is that when you divide like bases, you subtract the denominators. So let's try one last problem. Let's go with 50 x to the 8th, y squared, and we're going to divide it by 5, x to the 4th, y to the 1st. Okay, well, 50 divided by 5 is 10, of course. X to the 8th divided by x to the 4th, x to the 4th. 8 minus 4 is 4. Y squared divided by y. Well, 2 minus 1 is 1. There we go. Piece of cake. All right, you get some practice with this tomorrow and over the weekend, and you guys have a short week next week. I'm so jealous you're off on Friday, but I am here. Mr. Lawrence signing off. Have a good night, everybody.